some of our radical equations can start to get a lot more difficult. We're going to solve this by hand, so I'm going to show you how we can use, turns out, factoring to solve a problem like this. In the next video, we'll take a look at how we can solve an equation like this graphically, which may be a little bit easier to do, especially as they get very, very complicated. So in this video, let's take a look at how to do it algebraically. The next one, we'll take a look at how to do a even more difficult question, but we'll do that using the graphing calculator. So once again, I want to start by isolating my roots, meaning there's nothing outside of that root on that side of the equation. So that's already done. It's been isolated. So at first glance, it may seem no more difficult than what we looked at in a previous video. So I'm going to start with squaring to get rid of the square root. But when I square the other side, here's where things become a lot more difficult. I want to make sure that that entire side is raised to the second power. So in other words, I'm going to end up doing x plus 1 times x plus 1. I'm not allowed to distribute the exponent. I have to multiply x plus 1 by itself. When I square a square root, though, those will cancel out. So that's x plus, or 7x plus 15. Now, the reason that factoring is going to come into play is once I start to multiply this out, x plus 1 times x plus 1, I'm going to end up with x squared. So we are dealing, actually, it turns out, with quadratic equations when we do this. So if you need help reviewing factoring or how to solve by factoring, maybe now's a good time to pause this video and go back and watch one of the previous videos on factoring. I'm going to go ahead and multiply this in my head. Hopefully you can do that. If not, pause it and try the box method or FOIL to multiply that. So x squared plus 2x plus 1 is then equal to 7x plus 15. So if you recall, when we solved by factoring, and we're doing this again because I'm dealing with a quadratic, I want to be equal to 0. So let's go ahead and move everything to the left-hand side of this equation so we're equal to 0. So I'm going to have x squared minus 5x minus 14 equal to 0. And now that I've done this, now I'm going to go ahead and factor. Well, because there's just a 1 in front, factoring's fairly easy to do. If they've given you a nice one that will factor, which this one is, you may recall I need to find two numbers that multiply to negative 14 and at the same time add up to negative 5. Well, the two numbers that are going to do that are going to be negative 7, so I'll write x minus 7, and positive 2. Equal to 0. Now that I've factored, I'm going to go ahead and get my two possible answers. So one of them is going to be x equals 7. And again, if you need help with this part, now's a good time to go back and watch a previous video. Or x could be equal to negative 2. Well, hopefully you recall that we need to always check our solutions with these. Sometimes both will work, sometimes one works and another doesn't, and sometimes neither works. So I do have to check both of these solutions. And I need to check in the original problem. Not in any of my work. So let's go ahead and start by checking x equals 7. I suppose we might as well start there. So I'm just going to write down what I'm checking up at the top. So that's what I want to test real quick. So plugging in 7 to both sides. Obviously the left-hand side, 7 plus 1 gets me 8 on one side. On the other, I've got the square root of 7 times 7 and then plus 15. Remember, x is 7, so that's what I'm checking real quick. So 7 times 7 is 49, and adding 49 and 15 gets me 64. And of course, the square root of 64 is equal to 8. So yeah, 7 checks out. I get the same answer on both sides. So let me go back to my work and circle 7. It definitely checks out. Okay, let's try the negative 2 as well and see what happens there. So again, kind of side work over here. I'm just testing x equals negative 2. That's what I'm writing at the top. So let's plug in negative 2 for both x's in the original equation. Negative 2 plus 1 is negative 1. Is equal to, and even right there, you may, if you're really understanding what's going on and understanding square roots, you're probably knowing or being able to tell that negative 2 is not going to work out. So continuing though, I've got 7 times negative 2, both x's are negative 2, and then plus 15. So negative 7, or 7 times negative 2 is negative 14. And adding 15 to that gets me negative 1. 1 is not equal to the square root of negative 1. The square root of negative 1 is I. So it turns out we get a false statement, meaning negative 2 is an extraneous solution. I need to reject it. So make sure you go back to your original work and cross out that negative 2. There's only one single answer for this, and that is 7. So that's how this works algebraically, which is definitely a lot of work to do. In my next video, I'm going to show you how to solve a similar style equation using your graphing calculator. So maybe you want to watch that video instead and go back and try this one by graphing. But if you do, you'll see that it does just have one intersection point, and that's at 7, the one solution that we found.